if I want that to be linear, instead of graphing t versus b, we would graph t squared versus b. All right, y equals mx plus b. All right, m is the slope, which is going to be right in here, and we'll talk about that in a little bit. If I make x t squared instead of just t, I'm going to have a line. You follow? All right. So the two variables they're asking for here are d distance and t squared. That's what we want. We're going to graph, instead of time versus distance, we're going to graph time squared versus distance. And that, instead of giving us a quadratic relationship, should give us a nice linear relationship. Questions on how we come up with t squared and t? All right. So next time on this graph, this next one, it asks us to plot the data points for the quantities we identified in that previous part. And sketch with that straight line for the data. All right. So on our horizontal axis now, instead of t, we have time squared. The vertical axis is the same, right? Distance measured in meters. We include units on the bottom. What we do seconds squared. We're not going to take the time now, but you will then plot your data. So all the data on the front side, the d's you leave alone, but instead of time, you want to square each of those values, right? And then plot those points. And it should give you approximately a straight line. Sketch in that straight line. And then what would the slope represent? Uh-oh. What does the slope represent? It's on the paper. Y. Good. Slope is rise over run, right? If I do rise over run, meters over second squared, that's going to represent acceleration. That makes sense? All right. Notice also our equation, it's not going to be exactly the acceleration. This here is my variable, right? This here is my variable. Y equals mx plus b. Well, our y-intercept should be 0, so when you sketch your line, your y-intercept will be about 0. Notice we had the point 0, 0, so that should be right on there. The slope's not going to be acceleration, though. The slope, m, notice x is t squared, right? Wouldn't the slope be equal to 1/2 the acceleration? You see that? Where m is that? So what we're going to be doing is once you draw in your best fit line, you sketch it in, you're going to use 2 points on that line to find the slope. And then whatever you get your slope to be, maybe you get your slope to be 3, would be 1/2 a, so your acceleration would be 6. That makes sense where we're going with this. All right. Obviously, we're not doing a whole lot of it right now. But. All right. So these type of problems, and we'll practice these a lot more between now and May. What they ask you to do is, first, you always get your data. Remember, we're always going to label the horizontal and vertical axes. We're going to fill up most, if not all, of the grid that they give us. We're not going to squeeze it into the bottom quarter. But then it will ask you something about identify which variables produce a straight line. All right. In this case, t squared and d. Then you graph those, and then it'll ask you to come up with what the slope represents and to calculate what that, in this case, acceleration. Questions on how it relates to this class? We'll finish that up next class. You do not, no. All right, we've got about 3 or 4 minutes left. Your homework is on your handout. That is the homework. You don't need to finish that lab. That's going to be flat stuff because I want to kind of watch this. Make sure I get my clickers back, and you get started on that homework before the bell rings here in 2 minutes.